Hi, Huckleberry here, and today I teach you ARP, which I've had several requests from my viewers to do. That's Address Resolution Protocol. Not only will I explain what you need to know in an easy-to-understand manner, but I'll explain it in less than 10 minutes. Now, the first thing you want to know about a protocol when learning about it is where do you find the protocol on the TCP/IP stack? Here we see that ARP is located on the network layer, not on the data link layer, as some folks mistakenly believe. Here we see a LAN with 3 computers on it. Notice that each computer has 2 addresses, an IP address and a MAC address. The IP address is a logical address that the admin assigns to each host either manually or more likely with DHCP. The IP address is 32 bits long and is on the network layer of the TCP/IP stack. The MAC address is a physical address that is actually burned into the network interface card, or the NIC. The MAC address is 48 bits long and is on the data link layer of the TCP/IP stack. Now suppose we want to send a message from host A to host B. We start at the point where the network layer of the TCP/IP stack has just received a message to send from the layers above. This is encapsulated into a packet by appending a header to it, and it has the destination IP address in it. At this point, it is passed down to the data link layer, where a new header needs to be appended with the destination MAC address. The question is, how does host A know the MAC address of host B? The answer is, host A broadcasts an ARP request. So, to help us understand the ARP request, let's look at the ARP header for a second. So, we see we have a hardware type, a protocol type, hardware length, and a protocol length. These fields are less important. You can check those out later if you want. But let's start with the operation field. And either it's going to be a request, the operation field will have a value of 1, or it'll be a reply, in which case the operation field will have a value of 2. And then we have the sender hardware address, which is the MAC address of the sender. You have the sender IP address, which is the sender protocol or the sender IP address. Then you have the target hardware address. Now, the target hardware address is going to have a value of all zeros if this is an ARP request. And finally, you have the target protocol address, which is the target IP address. Okay, back to where host A broadcasts an ARP request. The reason it broadcasts is that it doesn't yet know the MAC address to send it to. The request is saying, if your IP address is 10.1.1.2, then tell me your MAC address. Let's see the parameters in the ARP request as they magically appear. Now both hosts, B and C, receive the broadcasts. C drops the request because its IP address does not match. Host B answers with an ARP reply. Let's see the parameters in the ARP reply as they magically appear. Now host A receives the unicast ARP reply, and it becomes aware of host B's MAC address and caches it. Also, when host B received the ARP request, it became aware of host A's MAC address and cached it. Note, therefore, that host B does not need to send an ARP request to find host A's MAC. So now both computers A and computer B are aware of the other's MAC address, so they can communicate back and forth over TCP/IP. Now let's look at a different case. Suppose that host A wants to go to the website PacketHacks.com. How does ARP work then? Host A should already have a default gateway of 10.1.1.4, which is the router that leads out to the network. So it does an ARP request to find out the MAC address of the router. When it receives the ARP reply back from the router, it caches that MAC address, and the router caches the MAC address of host A. Now, when host A wants to talk to the website PacketHacks.com, it simply sends all packets to the router, and the router is responsible for sending the packets on the next hop on the way to PacketHacks.com. So just to drive the point home, what are you likely to see in the router's ARP cache or the router's ARP table? Host A's IP and a corresponding MAC address, host B's IP and a corresponding MAC address, and also host C's IP and a corresponding MAC address. Because if host B or C had recently accessed any website on the internet, then these would be in the cache also. And also another entry with the IP and MAC of the next hop router to get to PacketHacks.com. That has been the end of this video. Thank you very much for watching. If you liked it, please mash down that like button and consider subscribing. Thank you.